Welcome to ClickMyProject.com. Our project title is Multi-Input a High Step-Up DC to DC Converter with Independent Control of Voltage and Power for Hybrid Renewable Energy System. The abstract is in this proposed work is designed for the multi-input DC boost converter. It's a converter based on the three converter will be boost, buck and buck boost. The three converters of use. The buck converter is the voltage will be reduce that, and the boost converter is the voltage will be boost that the voltage, and then buck boost is the voltage drop and then boost. So this is a three type of converters. This our project will be use the DC boost converter using the neural network controller. Is a three input source. One is the battery and then PV module and then fuel cells. The PV model is based on that solar based. So the battery and then fuel cell. Battery is the storage of capacity. After the three sources are connected in series, which is a fed to the boost converter is the loader. Finally is connected to the loader. Is the based on that neural network controller. This converter the switches are controlled. The using of the neural network controller we achieve the high efficiency and less switching stresses, etc. Flow diagram is three input source. The first of all is the PV module and then battery and then fuel cell. The PV panel is the two input source. One is the irradiation level and one is the temperature level. Two is the input level after the through to the PV model conditions. This is based on that irradiation level and then temperature level wise the partial shading connection. After that everything of the series will be connected. After the battery is using of the DC voltage of batteries. The PV panel also the DC voltage is through to the battery of the storage capacitor after the fuel cells. So overall to the DC to DC converter. DC to DC converter is of the DC to DC converter. So of the using of the boost converters. So voltage will be DC to DC. After that it is using for the neural network controller. The neural network controller based on the first of all training the data. After that the regression model will be plotted. How much of epoch will be set and then hidden layer will be set. So this is a neural network based on the control for the boost converter of DC to DC converter. After that flow to the loads. Load is the resistor of load. This is the based on the voltage will be calculator and then PV model calculator, battery, fuel cell, three based on the input and the one is the load will be output. This is the overall of circuit. It's based on the PV model. This is the PV panel of the circuit. After that connected to the neural network controller. The three base, one is the PV panel, battery and then fuel cell, and then connected is a resistor of load. The time will be set 5 and then run the simulation process. The 100% is completed beyond the 100% will be completed. The overall process will be completed. So this based on generate the data. This is the generation of data after simulation. Train the network. So this is the input and then output planet and error and neural network output. Network will be generated. This iteration will be the training process. This is the regression of plot. The regression of plot. Finally, the scope of output is a 73.28 will be reached. This is a fuel cell. This is a battery. Battery is a lithium nickel metal hydride battery will be used. The current